Systems engineering is not all about the process that results in the design and development of a solution. Systems engineers are also responsible for managing the process to ensure that it remains focused and delivers the expected outcomes without exposing parties to excessive risk. In this session, I'm going to look at some key systems engineering management issues and explain why they are important and what they achieve. I won't try to cover every conceivable element of systems engineering management, but rather give you a good feel for the types of management issues that arise. I'll look briefly at our interest in thoroughly and progressively testing our systems before handing them over to our stakeholders. The need for testing a system prior to use is self-evident, but what is sometimes not so clear is the time, money and risks associated with a comprehensive test program. Unless this is managed properly, waste will result and the testing program will fail to deliver the expected results. Managing the configuration of all of the elements of our system can be tedious, but if it's not done properly, we will sentence the through-life support stakeholders to a life of pain and frustration as they attempt to support our system whose configuration is not known. Imagine trying to modify a complex system when the system does not appear to be accurately documented, or when there seems to be significant variation in configuration across a fleet of systems that are meant to be identical. Risk is essentially the chance of something happening that adversely impacts on objectives. On a technical system development, there are plenty of risks that we face routinely. Should we use off-the-shelf systems or should we develop them from first principles? Should we use an experienced team of experts for technical programs, or should we use less experienced personnel? Maybe there are technical risks that need to be addressed by the design. For example, what's the severity of the risk of an aircraft losing electrical power to flight or safety critical systems? How can we reduce those risks by designing redundancy and using diversity in our design? Technical risk management is the focus of a lot of the things that we do as systems engineers. Speaking of risk, it makes absolutely no sense to set and forget the design and development effort and only check on it when it's meant to be completed. Instead, we tend to look for periodic reviews of our actual progress compared to planned progress. This allows us to address issues, answer questions, clarify conflicts, consider design decisions, and record rationales at discrete and logical points in our process. It also supports the desire of systems engineers to address problems as soon as possible, not as late as possible. You will recall from an earlier module that addressing problems as soon as they arise is the most economically viable and time-effective approach. Another critical part of systems engineering management that is strangely often overlooked is the need for systems engineers to consider the unique situation in which they find themselves. The process we described in this MOOC is just one example of how a systems engineering process might be structured. The approach we presented is often called the Waterfall Approach because the whole system is developed in one pass, starting at the system level at the top and then cascading down to the subsystem level and then finishing with the component level, in that order. I've heard some people say that the Waterfall Approach is outdated, dangerous and never works. In my view, this is just plain wrong. The Waterfall Approach can work, but it doesn't work all the time. It relies on a thorough and complete understanding of the problem and the desired solution. It assumes the accurate translation of all of that information into comprehensive system-level requirements. It works best when those requirements don't change very often. It assumes that technology is available and works best when that technology remains relatively stable over the course of the system development. It assumes that we have enough time and money to solve the entire problem in one pass. There's a lot of assumptions there, aren't there? Well, I've worked on projects where all of those assumptions were valid and in place. The waterfall approach was employed, and it was employed with great effect. So to say it's dangerous and never works is just not correct in my view. What I think those critics are probably saying is that it's not common to come across situations where all of those assumptions are in place. If any of those assumptions are not in place, systems engineers must think of alternative ways of executing the systems engineering process. Forcing a waterfall approach under unsatisfactory circumstances will expose the program to risk, such as cost and time overruns caused by potentially extensive rework, and the delivery of a system that's been based on invalid or out-of-date requirements. We're going to have a look at some alternatives to the waterfall approach in this session, but systems engineers must be capable of independent thought in this area and not just follow a process because that's how it's always been done. Once we've listed all of these things that we need to manage in systems engineering, it will come as no surprise to you that we've got some serious planning to do. We will certainly produce a governing plan out of all of this, but it's the planning process that's the valuable exercise. The plan is just the artifact that results from planning. The big thing to remember about planning is that it needs to be ongoing in order to keep up with the current situation. So let's now work our way through these areas and cover some of the major themes.
If you're interested in reading further into the topics we covered in this presentation, you may wish to read the corresponding chapters in the texts associated with the course.